Let's study 10th Standard ICSE Physics, Chapter 4, Refraction of Light, the Sums. Physics Chapter 4, Section A, Numericals. Question 2. Here the speed of light in diamond is given in kilometers per second. So multiply this by 1000 to get the answer in meters per second, because that's the SI unit. And we know the refractive index formula is speed of light in air or vacuum upon the speed of light in that medium, which is diamond in this case. So after substituting the values, we get 10 raised to 8, 10 raised to 8 cancel, that's 300 upon 125, and the answer is 2.4, no units of course. Next, the fourth sum, mark it as IMP. The old wavelength is given, the original wavelength, and the new wavelength is asked. Refractive index is given. The formula is the old wavelength is equal to the new wavelength upon refractive index. Substitute the values, 2 goes up, and the final answer is 3600 angstrom. That's 3600 into 10 raised to minus 10 meters. Next, the numericals of the B exercise. Let's do the second sum. Here they've asked us to calculate the angle of incidence, and angle of deviation is minimum, which is 36 degrees. It's an equilateral prism. That means the angle of the prism is going to be 60 degrees. Now the formula for angle of minimum deviation is 2i minus a. Actually the formula was I plus e minus a, but when the angle of deviation is minimum, I and e, that is angle of incidence and angle of emergence, are equal. So that's why we get 2i here. Now a, as I said, is 60 and delta min is 36 as given in the question. On solving further, we get the value of I as 48 degrees. And indeed, for glass it is 48 degrees for which the angle of deviation is minimum. Next, exercise 4C. Let's do the first and the third sums. In the first sum, it appears to be 2.7 meters deep. Appears means that's the apparent depth. And the refractive index of water is given. We have to find the actual depth or the real depth. So the direct formula is this. We substitute the values. 4 upon 3 goes here and becomes 4 upon 3. No, we don't reciprocal this. Calculate properly. And we get the real depth as 3.6 meters, which will definitely be greater than 2.7. That's common sense. Similarly, let's do the question number 3, which is IMP. The refractive index is given and it appears to be raised by 7 millimeters. That means the shift is 7 millimeters, and we've got to find the thickness of the glass slab, which is nothing but the real depth of the glass slab, the depth at which the postage stamp is kept below the glass slab. So we will use a direct formula here. Shift is equal to RD into 1 minus 1 upon mu, where mu is given as 1.5. So we do LCM out here. So this becomes 0.5 upon 1.5, which is 3. 3 goes up, and RD is 21 millimeters. So the thickness of glass is 2.1 centimeters.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.